Bright Cutie. Every student matters.
Hello children, welcome to the session. In this session children, we are going to start with one of the most interesting chapters, which is fun with magnets. So children, in this session we are going to learn what is a magnet. Then children, we are going to see the history behind discovery of magnet, at which place magnet was discovered and how was it discovered. After that children, we are going to learn how to distinguish between a magnetic and a non-magnetic substance. Then we are going to learn how to develop a magnet, and finally children, we are going to learn about the attractive and repulsive forces. So children, let us start with understanding what is a magnet. So what is a magnet? So children, the substances which attract iron particles or iron objects are known as magnets, and we have a large number of objects around us which uses magnet. The speakers that we have uses magnet, okay, and even the transistors have magnet. Also children, mics have magnet. And also, have you ever noticed while closing the door of this refrigerator, you feel certain force, right? You feel certain force. What is it? It is the magnetic force. Okay children, so let us now move ahead. So children, what is a magnet? A magnet is a material that attracts certain substances such as iron, and they are called as magnetic substances. Okay, and these are the different types of magnet. These type of magnets are called as children bar magnets, and this magnet, as you can see from the shape of it, this type of magnet is called as a horseshoe magnet. Okay, so these are the different types of magnets which are available to us. Okay, so children, what happens when you open the door of your refrigerator a little and then you leave it? It closes itself. It closes on its own. Even the handbag flaps that you have, they close on their own, and the mobile flaps also click shut in this manner. Why? Because they have magnets inside them, and it is the magnetic force which is responsible for all of these examples. Okay, so children, just keep your eyes open, observe around your surroundings, and I am sure you will be able to find so many examples of magnets. Okay, so let's now move ahead. So children, we have an interesting example of maglev trains. So children, these are a type of trains which have no wheels. These are the trains with no wheels, and children, you know, they are based on the principle of magnets, right? It just floats in air on the tracks, because these tracks use magnet, and these tracks are called as guideway. So let's just read about such trains. These are the maglev trains. They have no wheels, first thing, and it floats in the air and uses the magnets to float above the track. It uses the magnet to just float above the track. And children, whenever the normal trains which move on track, they experience a force of friction. Okay, and no such frictional force is experienced in these maglev trains, because there are no wheels and they are just moving in the air. They are floating in air, so they can travel at a very high speed, which may range from 500, which may be equal to 500 kilometers per hour, as fast as 500 kilometers per hour. Okay children, so isn't it very interesting, right? So let's now move ahead. So children, there are a number of devices which uses magnets, such as doorbells, televisions, computers, electric motors, your telephones, electric generators, right? All these floppy disk, speakers, credit cards, all the ATM cards, vacuum cleaner, all these devices have magnets inside them. Okay children, and you will be able to identify also them on their own. Okay, on your own. So let's move ahead. So children, now we are going to understand and discuss the discovery of magnets. How were these magnets discovered? So children, it is said that there was a Greek shepherd Greek shepherd, and his name was Magnus, and the area was Magnesia. So magnet was discovered thousands of years ago at Magnesia, and it is located in Asia Minor. So children, the tip of this shepherd stick that he had a piece of iron in it. Okay, so this was made up of iron. So when he was moving around, there was some black stone to which this magnet got stuck, and he experienced so much force that he was not able to take it away from that stone, and that is how he discovered this stone as magnet. Okay children, so accidentally magnet was discovered. So let's just read about it. A black colored rock was discovered which could attract small pieces of iron, and it was initially known as magnetite. As you can see, this black stone, this was known as magnetite. Okay, and some persons believe that the first magnet was discovered by the Greek shepherd named Magnus. Okay, so there was a Greek shepherd, there was a shepherd named Magnus. Let's just recall everything about the discovery of magnets so that you don't forget it and you remember it for a longer time. Okay, so children, there was a shepherd named Magnus who lived in ancient Greece, and he took a stick with him to control his herd. Okay, the stick had a small piece of iron attached to its other end, this end, and one day he had to pull hard to free his stick from a rock, and this is how accidentally he was able to discover a black rock which was called as magnetite. Okay children, so you have to pay attention to each and every small details, because these questions can be asked as a one marker question. For example, in which area magnet was discovered? So it was discovered in Magnus in Asia Minor. Okay, so these type of questions can be asked as a one marker question. So children, the stick which was being attracted by the rock was natural magnet. Okay, nowadays children, we have artificial magnets as well, but at that time this black stone was actually a natural magnet. It was a natural magnet, and it attracted the iron tip of the shepherd stick. Such rocks were given a name magnetite, and these magnetite contain children iron. The component of magnetite is iron. Then magnetite was first discovered at a place called Magnesia. Children, you have to remember each and every detail. Just pay attention and listen to it like a story. Okay, and then you won't be forgetting it. Okay, so children, let us now move ahead to the next point, which is natural and artificial magnets. So children, as the name suggests, the magnets which are found naturally are called as natural magnets, and okay children, so magnets which were found naturally are called as natural magnets, and later on the process of making magnets from pieces of iron was discovered. Later children, there were methods which were devised to create artificial magnets. Okay, and the magnets which were created artificially are known as artificial magnets, and the magnets come in various sizes and shapes. They come like a bar magnet. Then we have a cylindrical magnet. This is the horseshoe magnet, and this is the magnetic needle which is usually found in compass. Okay, this is a small needle which is found in compass, which is used to find the direction. Okay, then children, let's see, if a question comes, how you define a natural magnet or artificial magnet. So there are two types of magnets, natural and artificial. Natural magnet, the lodestone or leading stone is called as a natural magnet, and the magnetic properties of this magnet are very strong, but the magnetic power is low. Okay children, so these are not very strong magnets, but artificially we can create a magnet of our desired strength. Okay, for example, the magnets that we use in cranes to lift heavy objects are made very strong. Okay, whereas some other magnets, like in refrigerator or in microphones, the magnet used is of small power. Okay, so what are artificial magnets? These are man-made, and these are much stronger in comparison to the natural magnets, and these magnets are made in various shapes and sizes as per our need for them. Okay, Then let's move ahead, and we are going to do an interesting activity and see the effect of magnet. So children, what we are going to do is we will take a stand like this, and we will hold a container, take a container, and in this container we are going to place a piece of magnet, okay? And to this base of the stand, we are going to tie a thread, and to this thread we are going to attach an iron pin, okay? And children, once you place this magnet over here, you will see that this pin is attracted towards the magnet and it flies upwards towards the magnet like a kite. And if you try to move this magnet, this pin will move along with it. So children, this is the property of magnet. This is the magnetic property, okay, to attract a piece of iron. So children, what we have done in this, let's see the procedure. Take a plastic mug, fix it on the wooden stand, place a magnet inside it, and tie paper clip with the thread and fix its other end at the base of the wooden stand. So what we have done, we have taken this container, plastic mug, in it we have placed a magnet, and with the help of a thread we have tied this pin which is made up of iron. So what did we observe? We observed that the clip raised in the air like a kite. Now move the magnet around the clip slowly, and the clip will move along with the magnet, okay? So children, this was the effect of magnet, okay? Then children, we are going to study about what are magnetic and non-magnetic materials, okay? So children, most of the metals are magnetic materials. So children, the substances which are attracted by a magnet, mostly metals are attracted, and they are called as magnetic materials. And common examples are iron, cobalt, nickel, etc. You can also observe this in the picture. We have a nickel knife, cobalt coin, we have steel spoon, iron nail, and paper clip. All these which are made up of metals are magnetic materials because they can be attracted by a magnet, okay? Then next children, we have the substances which are not attracted by the magnet are called as non-magnetic substances. For example, aluminium, copper, brass, and plastic. Paper, glass, plastic, rubber, wood, all these things are children non-magnetic materials, and they cannot be attracted by a magnet, okay? So let us now move ahead, children. We are going to do an interesting activity wherein we are going to play a little with the story of invention of magnet. Just we are going to replace the position of magnet and the stick that our shepherd had. What we are going to do is, children, we will take the shepherd stick and we will place a piece of magnet at one end of the stick, and we are going to find iron objects. We will take it at different places, and you will find that all the iron objects start clinging to the stick, okay? So let us walk in the footsteps of Magnus. Magnus, who was Magnus? He was the Greek shepherd who discovered magnet. And only this time what we are going to do is we will change the position of the magnet and the iron. There will be a magnet at the end of our shepherd stick, okay? We have taken magnet at the end of the shepherd stick. We can attach a small magnet to a hockey stick. We can use a hockey stick as well, or any other stick that you find, okay? Now let's go out on a Magnus walk, okay, through the school playground. And what does our Magnus stick pick? What will it pick? It will pick different iron objects, okay? You can also take a magnet, touch these objects. So children, you are going to touch different objects and find whether they are attracted towards the magnet or not. In this way you will be able to identify which of the materials are magnetic materials and which are non-magnetic, okay? And later you will tabulate in this observation table, and this observation table will contain, children, 3 columns. First is the name of the object, second is the material that you are testing, and finally whether it is attracted to our magnet stick or magnet or not. For example, if we take an iron ball and it is made up of iron and it is attracted towards our magnet stick, so it is a magnetic material. It is a magnetic material. Then if you take a scale which is made up of plastic and it will not be attracted towards our magnet stick. Next we take a shoe and which is made up of leather, and again it will not be attracted towards our magnet stick, and therefore it is a non-magnetic material. Both of these are non-magnetic. So children, in this way you will be able to figure out, you can test as many objects or materials as you want, and you will find out which of the materials are magnetic and which are non-magnetic. Okay.
Identify the magnetic substances from non-magnetic substances. Materials required: iron nail, bar magnet, silver spoon, paper clip, wooden chair, notebook, plastic scale, common pin. Method: keep all the objects in a place. With the help of a bar magnet, touch each object one by one. Iron nail, paper clip and common pin get attracted by the bar magnet and can be removed from the rest of the objects. Silver spoon, plastic scale, notebook and wooden chair are not attracted by the bar magnet. Conclusion: you find that iron nail, paper clip and common pin are magnetic substances and rest of substances are non-magnetic.
So children, before moving ahead, our friend Bujo has a question for you. He is confused that a tailor was stitching buttons on his shirt. The needle slipped from his hand on the floor. And can you help the tailor to find his needle? What he can do is, children, the needle is made up of iron, which is a magnetic material. So what we can do is, we can take a piece of magnet and we can put this at one end of the stick, and we can take this stick everywhere in the room where the needle could be found, and you will observe that, and children, you will observe that this iron needle will be attracted towards our magnet stick, and in this way we can help the tailor find his needle. Okay. Now children, we are going to test and check for any iron articles which may be there in the soil. So we are going to take a mixture of soil and bring a magnet towards the soil, and you will observe all the iron particles that might be there in the soil will get attracted towards the magnet. So what we are doing, rub a magnet in the sand or soil, pull out the magnet. Are there some particles of sand or soil sticking to the magnet? Now gently shake the magnet to remove the particles of sand. Are some of the particles still sticking to it? These particles which are still sticking to your magnet, children, these are the small pieces of iron or maybe iron fillings which you have picked up from the soil. They had the magnetic properties. Okay children, so in this way you can find out the iron objects anywhere. Children, we are going to discuss about the poles of a magnet. Up till now children, we have discussed what are magnets, and we defined the magnet as the material which can attract iron objects, right? Then we discussed about two types of magnets, artificial magnets and natural magnets. Natural magnets occur naturally in nature, whereas artificial magnets are man-made. Okay children, after that children, we had done an activity where we found that we had certain amount of sand or soil. To this we brought a magnet close towards this, and we rubbed the magnet in this sand or soil, and after some time we observed, even after shaking the magnet well, some of the sand particles were clinging to the magnet. What were those? Those might be the iron fillings or the iron particles that are present in the sand or soil. Okay, so children, while we did this activity, you might not have observed it carefully, but I would suggest you to do this activity once again, and you will find out that the magnetic particles were attracted more towards the edges of the magnet. And children, these edges of the magnet are called poles of the magnet. Okay, for this we are going to do an activity. We are going to take a bar magnet. Okay children, we are going to take a bar magnet, and we will, in a plate or on a piece of paper, you can take iron fillings. Okay, and you will bring this magnet closer to the iron fillings. You will observe that all of these iron fillings cling to the bar magnet, but they cling to the bar magnet in a particular pattern. And what is the pattern? Most of the iron fillings were attached or were clinging to the edges of this bar magnet, and these edges were called as, children, poles of the magnet. These are the poles of the magnet, right children? And these poles are defined as, or they are labeled as, one pole is the north pole, whereas the other pole is the south pole. The pole which is on your left hand, that is named as north pole, and the one which is at your right hand is named as south pole. Okay, so a bar magnet has two poles, north and south pole. Okay,
To show that the strength of a magnet is maximum at its ends. Materials required: bar magnet, common pins, plastic plate. Method: take a plastic plate and on it spread about 100 common pins. Place a bar magnet in the plate. Now lift the bar magnet. Maximum pins cling at the ends of the magnet, whereas no pin clings at the center of magnet. Conclusion: the strength of magnet is maximum at its ends.
so children, after this activity, what you can conclude? You can conclude that the magnetic force is greater at the poles as compared to the center of it. Okay, that is why most of the iron fillings were clinging to the poles. Okay children, so what we can conclude? We can conclude that the magnetic strength is stronger at the poles than in the middle of it. Okay, so children, we have one more important point to discuss with you, which is magnetic poles always exist in pairs. Okay, they always exist in pairs. Suppose we have this large bar magnet, so it has two poles, north and south. So now what will happen if we cut it into two equal parts? When we have cut it into two equal parts, so children, each part 1 and 2 will have its two poles. It has its north and south pole, and this also has its north and south pole. Now even if we break it even further, we make two pieces out of the first one and two pieces out of the second one, you will observe that even these tiny magnets have their own poles, north and south, right children? So children, the poles of the magnets always exist in pairs. Okay, no matter how small a magnet is. Okay, so that's it guys, this was all about the magnetic poles. Thank you so much for your attention.